Question number 3. Stokes has shown that force equals to K R raised to power A V raised to power B coefficients of viscosity raised to power what? C, where A, B, C are unknown powers. Using dimensional analysis, show that force is equals to 6 pi RV coefficients of viscosity. When as a solution, force, which we know as mass times acceleration, K, which is the constant, R is radius, which is meter. Look at the unit, meter. V is meter per second, which is velocity, all raised to power B. Coefficients of viscosity raised to power C. Then mass is measured in kilogram. Acceleration is measured in meter per second squared, equals to constant K, M, which is the meter, the radius, the unit of radius, raised to power A. Then this meter per seconds can be written as meter seconds raised to power minus 1, B, and the coefficients of viscosity. Then resolving this, we have kilogram meter per second squared equals to constant meter raised to power A and meter seconds raised to power minus 1, all raised to power B, coefficients of viscosity. Then this can be written as kilogram meter per second squared equals to constant meter raised to power A, M, meter seconds raised to all raised to power B, coefficients of viscosity raised to power C. Then dimension of kilogram is capital M. Dimension of meter is capital L. Dimension of seconds is capital T. And all raised to power minus 2. K, constant, remain constant. Dimension of meter is capital R. Dimension of what? Meter per seconds is capital L T raised to power minus 1. All raised to power B. Coefficients of viscosity. Dimension of coefficients of viscosity, which we have already done in our class 4. We have done this in the class 4. Coefficients of viscosity, dimension of coefficients of viscosity have been done in class 4. So if you are following our series, you go in class 4, you will get how the coefficients of viscosity have this dimension. Dimension of coefficients of viscosity is capital M R raised to power minus 1, capital T raised to power minus 1, R raised to power C, which is this. We have removed the coefficients of viscosity and put its what? Dimension. Then opening this bracket, if we open this bracket, I have that what? K, opening this bracket, this L will be raised to power A, and the R here will be raised to power B, and T raised to power minus 1 will be raised to power what? Minus B. If I open the bracket, this will be what? Times every power. If you open this bracket, the power here will times every power that is inside this bracket. If I open this bracket, the power here will times every power that is inside this bracket. And this L has a power of 1. Then 1 times A will give me L raised to power A. Then this L here have a power of 1. B times 1 will give me L raised to power B. This T is having a power of minus 1. Minus 1 times B will give me minus B. And that's what we have here. Coming here as well. This power will times every power of this what? Value here. M here is raised to power 1. And 1 times C will give me what? M raised to power C. Here L is raised to power minus 1. And minus 1 times C will give me minus C. And T is raised to power minus 1. Minus 1 times C will give me minus 1 C. That's how we get it. Then all these are multiplying themselves. Therefore, we are going to collect what? The like term. Since they are multiplying themselves, this and this is of the same base. Watch it. This, and this is of the same base. So what do? We add their power. Because they are multiplying themselves, this and this and this are multiplying themselves, and they are of the same base, we add their power. Come over here, you see how we add their power. It become L raised to power A plus B minus 1C. Look at it here. Come down here. L raised to power A plus what? B plus minus what? C, which is same thing as what? Minus C. Plus minus will give me minus. Then coming down here again. We now see that T, capital T, and capital T here are the same base, and they are multiplying themselves. I will add the what? Their power. And adding their power, I will have this to what? Capital T raised to power minus B minus C. Then we'll come down here again. Capital M is the only one here, which is capital M raised to power C. That's it here. Then coming to this, come over here. I have M here is raised to power 1, and L here is raised to power 1, and T here is raised to power 1 minus 2. Come over here, you see M raised to power 1, L raised to power 1, and T raised to power minus 2 equals to L raised to power A plus B minus C, T raised to power minus B minus C. Then now, you now look at this. MLT, LTM. They are the same base. MLT, LTM, they are the same base. M is here, L is here, T is here, L is here, T is here, M is here. They are of the same base. Since they are of the same base, we equate their power. Since this equation here and the one that is here, the value here and here of the same base, we equate their power. That means I will equate M to what? M. Power of M to power of M here, and power of L here to power of L here, and power of T here to power of T here. That will mean by equating their power. Then I cannot say that what? M, which is what? C, is equals to 1. This C, power of what? M here, is equals to 1. That's what I say. Therefore, C is equals to 1. I have gotten the value of C. Then I cannot say that what? Minus B minus C is equals to 1. Look at it here. Is equals to what? 2. I mean to say minus B minus C is equals to minus 2. And I say minus B minus C is equals to minus 2. But I know C to be 1. I put the C here. And I'm making B subject of formula. This one coming over here become plus. And here will become minus B. Minus 2 plus 1 will give me minus 1. Then multiply 2 by minus 1, I have B equals to 1. Multiply 2 by minus 1, I have B equals to 1. Then now, I come over here, and I say A plus B minus C is equals to what? 1. A plus B minus C is equals to 1. And that's what we did here. A plus B plus C minus C is equals to 1. But I know B to be 1, and I know C to be 1 as well. We know C to be 1, and we know B to be 1. Then I will substitute 1 for B here, substitute 1 for C here, I have this. And this will become 0. That shows me that A is equals to 1. Then I have obtained the value of A, B, C. Then going back to the equation they gave me, the equation they gave me is what? K, F equals to what? K, R raised to power A. That means A now is what? 1. Then V, which is raised to power what? B. That means what? B now is equals to 1. Look at the equation they give me. F equals to what? K, R raised to power A, V raised to power B, and the coefficient of viscosity raised to power C. And we find out that A, B, C are all 1, 1. Putting them there, I will have this to be what? K, R raised to power 1, V raised to power 1, coefficient of viscosity raised to power 1. And where this K is a constant, which is what? 6 pi. This K is a constant, which is equal to what? 6 pi. Substituting this 6 pi in this equation, I will have this to be what? F equals to what? 6 pi R V N. And we have proved it. We have shown that this is same thing as this. So that what they asked us to see. That will say what? Proof. We have proved what? The question. Thank you.